Hi, this is a deep dive on how to do whole system mapping. It should help you make systems thinking more concrete and actionable, and should help turn sustainability from a burden into an innovation tool by making your brainstorms more thorough and more radical. So you learned from the introduction video that whole system mapping has 4 activities. Number 1, draw the system map. Number 2, set priorities with LCA. Number 3, brainstorm solutions on the system map. And number 4, decide on winners using your priorities. This video shows how to do all that, but using the example of a refrigerator. And while it's best to do whole system mapping in person with sticky notes and a whiteboard or a big sheet of paper, lots of stuff is now online, so I'll show you how to do it through online collaboration. I've created a Google Slides doc, so any number of people can log in and edit together simultaneously. And I've filled it in with templates of the activities with 1 slide per activity. And each slide has notes on how to do that activity well. And I've also put 1 slide in at the beginning with an example of the system map. Now, finally, you'll notice it says Team 1 on all these slides. If you're a teacher or a consultant training a bunch of people, you can break them out into different breakout rooms so that each team can work on their own product, but everyone can still work in the same document. And you can easily jump between teams as the facilitator to coach people. So you see, if I just scroll down here, I get another copy that is Team 2 of all these same slides. And so that's how I'll do it in this video. But back to whole system mapping. So like I said, we're using the refrigerator as the example, and getting into activity number 1, drawing the system map to define the problem and think of the larger system as well. So what is the whole system of a refrigerator? Well, first of all, you need all of the parts of the refrigerator. So the structural case, the plastic walls inside, the doors, the shelves, the cooling coils, and the compressor, all that stuff. You might not need to include every single nut and bolt of your product, but you can go into whatever level of detail that you want. And I recommend at least the major subassemblies. So things that you want on your system map besides just the bill of materials components, that's what you start with, but then also the full life cycle of the product, from raw materials extraction and manufacturing and the transportation involved there, maybe retail, transportation and display, and then the use phase, the electricity during the life of the fridge, and what happens at the end of life. So in this case, I drew landfill. And then there's the user interaction. What does the user actually do with the fridge? Well, they open the door, they look inside, they take food out, they put food in. And what else is the product used with? In this case, obviously food. And so here I've drawn the whole life cycle of food as well. And you may not need that level of detail in your system map, and that's fine. There's not really one right way to do this. It's what's helpful for you. But one last thing that I do think is important is the connections between these. So you see all these arrows. Here they're showing transportation, but they can also be showing the flow of time through the system or the flow of goods through the system. And in gray text down here, there's also things that you might consider if you're using whole system mapping for something other than a normal physical product. So are you using it for a service or software or government organization or things like that? You might consider other things in your system map like relevant policies or training organization. But for normal hardware products, just the things in black are plenty. So let's try this. And we can go back to our shared template here and start drawing on the system map. So you can see we've got this little sample post-it note. So a nice thing about working with virtual post-it notes here is you can resize them, you can move them around and just reshuffle things when you need to. You can copy and paste. So these are putting in all different major components of the bill of materials and, playing a little bit to make it look a little bit like a refrigerator. And once you've got the full bill of materials, all the components, then you can get onto the life cycle stages. So raw materials, assembly and manufacturing, etc., some transportation, and transportation at end of life to landfill, and then the electricity used during the life of the fridge. And what's the user interaction? And again, it's mostly opening the door to put food in or take food out. And then naturally, what is the other thing that it's used with? It's used with food. And if you want, you can throw in some little graphics here just to spice things up a bit. The one thing I would say to not do is don't add colors, because when you use this for brainstorming, you're going to want a different color then to distinguish your new ideas from the existing system. So it's best to keep all of your system ideas a single color. But throw in that last thing. We need all the connections between these things. And so that can be it for putting together the system map. It doesn't have to be pretty if it's a working document here. But the important thing is to have the ideas down there and to have space to work on, because this is going to be a working document. So then the next step, prioritizing your objectives using LCA. And you actually don't have to use LCA. You could use other scorecards like Cradle to Cradle certification or EPEAT certification. Anything that can give you direction and help you set your priorities, that's what you want. And so, but LCA is great at helping you set your priorities. So that's what I'm going to show you. And you don't have to consider your entire system map when you're doing the LCA. You can draw boundaries around the things that are relevant to you. Like you say, we're a refrigerator manufacturer. We're just going to look at the fridge. We're not going to include farming and the whole rest of the food system. That's totally legitimate. Whatever you think is the reasonable boundary there. But then you do the calculations, or you look up calculations that have been done by others to see where the biggest environmental impacts come from. And in the case of a refrigerator, it is energy use. And you can look at these different graphs that I have on the VentureWell website for different product categories. If you don't have the time or skill or expertise to do LCA, you can just start with one of these basic ideas. Or there's a new site that I've recently launched called productdesign.green that has a more extensive list of product categories and LCAs. And so you can just say, if we were doing small electronics like a Fitbit or a cell phone, then the materials in your electronics would be your top priority, not the materials in the metal or plastic case or the energy use or other things. Or if you're doing t-shirts or other apparel that's frequently washed, it's kind of a mix between the materials and manufacturing and the energy use of washing and drying. And you could choose either one of those to be your top priority, or you could do this exercise twice so that you do both. And then if you're doing furniture or other housewares and stuff, it's really probably going to be the materials in manufacturing. You notice that transportation is almost never a dominant impact. That's true for almost all product categories. Once you're done with the LCA or looking up an existing LCA, you want to set your priorities. So in the case of the fridge, it's just like the washer in the video where energy use is our top priority. And then you want to include some kind of business priority. Let's say user convenience and price. Those are good standard ones. And you might do more priorities than this, but more is not better. But let's go back to the template. So it's got this template already set for priority 1, priority 2, priority number 3. And the notes at the bottom say you want at least one sustainability priority and one business priority or user priority. So you could only have 2 priorities. That's fine. And you could have 4 or 5, but more is usually not better. It usually just makes things more complicated and difficult. So let's say that the priority number 1 is minimize energy use. Although actually, that's kind of a limiting priority. If we want to open it up to more possibilities, we could say minimize impacts from energy. And so that means we could both minimize energy use and just choose greener sources of energy as well. And then for priority number 2, let's say user convenience, because that's a classic one. And priority 3, let's say cost again. And so what this is doing is this is basically creating a brainstorm question where the brainstorm question will be, okay, and so we can make this in a more reasonable font size. Okay, so you can have that there to remind yourself of what you're doing. So then step 3 is to brainstorm new solutions on your system map. And like all brainstorming, you want to defer judgment, go for a lot of ideas. I know it's hard to be visual when you're doing the online system like this, but if you can, headlines, stay on topic, and encourage wild ideas. Now, what makes this different from a normal brainstorm is that when you brainstorm on the system map, you can see where you do have ideas and don't have ideas. And what you want to do here is make sure you have at least one idea for every node in the system, every part of the system, or every step in the process. So here we've got a bunch of ideas. You can see we've got several ideas for the bill of materials hardware. We've got several ideas for how the doors open and close. We've got one idea for electricity, but we don't have any ideas for raw materials or end of life. We don't have any ideas for transportation, etc. And so that means we need to keep having more ideas. So here are more ideas. Okay, now we've got some more manufacturing ideas. We've got even more new ideas for the structure here, but let's keep going. Okay, now we've got an idea for end of life, reuse components, recycle material, repair, and we've got some new ideas for materials, and we've got new ideas for energy types as well. So those are examples of how this can give you more thorough brainstorms, is by going through and making sure you have at least one idea for everything on the system map. And then the other way that whole system mapping can help you is by making more radical brainstorms by eliminating parts of the system. So how can you have ideas that eliminate one or more nodes on your system map, one or more components or one or more steps in the process? So like growing food inside the fridge, that eliminates the whole supply chain of food. And having the fridge dispense food as a liquid through a faucet, that eliminates a bunch of components, the door and the hinges and some of the shelves, etc. And then these ideas up here, salting food, canning food, drying food, they actually eliminate all of the hardware of the fridge. So you can see that the more radical the idea is, the more of your system it eliminates. And to do that in this little template here, first what you do is copy and paste your system map. So, okay, so I'll get rid of this. And I'll select everything in my system map. Okay, but not that text. Okay, so copy and paste that. Okay, so now I have my system map here. All the yellow post-its are going to be the existing system, and all the green post-its are going to be new ideas. So yeah, let's put in some of these ideas. Okay, maybe the electricity is solar panels on fridge. And I'm just going to fast forward through this so that you don't have to sit through the whole thing, but, have a nice solid brainstorm for a good long time. So yeah, this is the kind of brainstorm that you might end up with. And as you can see, we've got at least 5 ideas that eliminate part of the system, because I put them in bold to show where they eliminate things. You could mark them in some other way too. If you want, you can make them a different color or something. And we've got at least one idea for every part of the system here. You can just look around and see it. And you can see it is a little messy and crowded in some places, but if you wanted to, you can fix that by just creating a second page. You can copy and paste this into a new page and just start over and say, okay, we'll delete all that. We will paste in a new copy of the system map, and we'll start making new ideas here. And you could fill up a whole second page of brainstorm ideas. And you could have one page for bill of materials ideas, another page for life cycle phases ideas, etc., etc. And so the last activity you want to do is to decide on what ideas you want to move forward with based on the priorities that you set in step 2. And you're going to do this with LCA, but you don't want to do an LCA of all of your ideas. So you want to start out by just eliminating everything except the best, like 3 to 5 ideas. So go back to your brainstorm here, and I recommend dot voting. It's super simple. If you've never done it before, just every person has 3 dots to vote with, and so they can say, all right, I'm going to give 1 dot to this idea here, 1 dot to this idea here, and maybe 1 dot to this idea here. Or you might say, actually, I really love this one idea. I'm going to put all 3 of my dots there. And once everybody votes, you'll have a whole bunch of dots, and usually there'll be 3 to 5 ideas that win. And so then you can go and do an estimated LCA of those. And what you'll get is you'll have the LCA of your existing design, and then some scores for these different design ideas. And remember that there'll be a huge amount of uncertainty going on here. Actually, what I've drawn here is actually a very moderate amount of uncertainty. You may be plus or minus 50% or more even in the energy performance, because that's what our priority was here with the refrigerator, was energy performance. But even when there is a large amount of uncertainty, you can still see that some of these ideas are just clearly worse than others. And so we can eliminate it down to these probably best 3 ideas. And then ideally you go through and do a decision matrix on these, where you say, what are your design brief priorities and how important are those? And how well does each idea score on those? So let's say our 3 favorite ideas are a glass door so that you can see inside without opening it, and let's say vacuum panel insulation, and let's say putting solar panels on the fridge. Okay, just randomly saying those are our 3 ideas. So in the decide phase, those are the ideas that we're going to look at. And then we can just delete this. Priority number 1 was minimizing energy use or energy impacts. You could also just say LCA score here if you want. If you're good with LCA and have a model, then it's easy to run through that. But if you don't have that, then it's easier to estimate one thing like energy performance. And then priority number 2 was user convenience. And number 3 was cost. And then we can delete that. Okay, so how important are all of these things? On a scale of 1 to 5, you might be tempted to say that our top priority is 5, our next priority is 3, and our last priority is 2 or 1. But there's a huge difference between a 5 and a 1 or a 2. And so cost is still probably very important. So let's say that's a 3, but let's say that it's equal to user convenience. Let's say they're both equally important. And so how will these different designs score on those, just qualitatively speaking? If we say that on a scale of 1 to 5, if 1 is much worse than the fridge that we have now, and 5 is much better than the fridge that we have now, and 3 is exactly equal to the fridge that we have now, well, what does the glass door do? Well, the glass door, energy-wise, it means that you don't have to open and close the fridge all the time, which should save energy because you lose cold air every time you open the fridge. But glass does not insulate very well. So let's estimate that this is maybe a 2 on a scale from 1 to 5, because it'll actually be slightly worse than a normal fridge because of less insulation. But user convenience, it'll be awesome because you can always see what's in your fridge. You never need to open it up. So that's actually more convenient than a normal fridge. And then cost-wise, I don't know. Let's say it costs about the same. And then vacuum panel, minimize energy impact. Yeah, vacuum panel is the best insulation you can get. It's the best insulation that exists, basically. And so that'll help energy performance a lot. So let's say that's a 5. User convenience, the user isn't going to notice, or actually, because vacuum panels are both better insulating and take up less room than traditional insulation, you can have a thinner wall fridge, so you can have more volume of space on the inside for your food without making the fridge any bigger. So let's say that this actually increases user convenience a little bit as well. But the downside is that vacuum panels are expensive. So let's say that it's a 1 for cost. And then solar panels, the light from inside your kitchen is generated electrically with whatever grid electricity you have. So that's not actually an improvement. If you have solar panels that go outside the building and then you're cutting a hole in the wall to run the cables in, that might still be okay if you do a good job of insulating the hole that you cut in the wall. But I'm going to guess this is a little dicey. So let's actually say that this is not going to do a whole lot. And then user convenience, it's not going to help the convenience at all. Let's say it's inconvenient because it'll involve cutting a hole in your kitchen wall. And then cost-wise, yeah, it will add a good deal of cost. But so how do we calculate these total scores here? Well, we have 2 times 5, because that's how important this category was, plus 5 times 3, because that's how important this category was, plus 3 times 3. So that is 34. And then vacuum panel, Okay, so we see that the vacuum panel got the highest score here. And so we can say, great, that is the winner. That's the idea we're going to move forward with. Or you might decide that actually these numbers look wrong. And so that means that I need to either reevaluate what I think the scores are for the different things, or I need to reevaluate what the weights are, what my priorities are. And so this is not meant to be a tool for you to slavishly follow. It's an idea to help your own critical thinking by keeping track of a bunch of different variables at the same time. And you can also decide things like, hey, maybe we want to combine ideas. Maybe we want a fridge that has vacuum panel insulation and a glass door. Maybe there'll be other ideas that you want to incorporate as well. There doesn't have to be just one winner. Again, use your critical thinking and design creativity and judgment here. So that's it for whole system mapping. The process could take you an hour or two, or you could repeat it for weeks at a time, iterating your problem definitions from energy use to long life, material circularity, changing user behavior, anything you want. And again, the main benefits are to provide you with more thorough and radical brainstorms and to make systems thinking more concrete and actionable, because that's the level of thinking that can turn sustainability into an innovation tool.